All right. Good day, everyone. I'm busy thinking if it's good day or good morning. All right. Good day, everybody. Welcome to Life Sciences Grade 11. My name is Duduzile Kupeka. We are continuing with the topic of human gaseous exchange. Now, guys. So remember we had started off, we discussed this part yesterday, the external structure of the lungs, where we discussed that the lungs, on the external structure of the lungs, you have the lungs, you have the pleura, which is the double membrane that covers the lungs, that is protects it. And it also does what? It protects the lungs. It's like a shield, it forms a shield for the lungs. You have the pleural fluid, which is there to keep it moist and reduce friction during breathing movements. So the fluid there is between the pleural membranes. Then you've got the entrance points for the bronchi, which transport air to the lungs. It's linked to internal transport passages and gaseous exchange surfaces. Then we have the pulmonary arteries and veins. The structure here is that the artery walls are smooth muscle fiber that can contract and relax. Then the walls of the veins are 3 layers of thinner, less elastic tissue. So we discussed these two. Arteries are more flexible and more elastic as opposed to the veins, which have the three layers. There are 3 layers which are thinner and are made up of less elastic tissue. These, what do? They transport gases to the heart, to the lungs, and back to the heart again. So these are very important structures that you need to understand. So whenever you're asked about the external structure of the breathing system, the external structure of the breathing system, you would understand that you need to label the lungs, the pleural fluids, entrance points to the bronchi and pulmonary arteries and veins. Then the internal structure of the lungs. This is the external one we discussed. The pleura is the one thick lining here. You see that is protecting the lungs. Pleural fluid will be in between this lining. So in between the lungs and the membrane here would be that fluid that will protect, and it's moist so that it reduces friction throughout the lung movements when it breathes. Then you have the pulmonary arteries and veins underneath there. And now we were gonna go to the internal structure. We know this is the bronchi. We have 2 bronchis here. One merging into the left lung and the other one merging into the right lung. So we have 2 of them over here.
Each lung is divided into lobes. The right lung is divided into 3 lobes, while the left lung is divided into 2 lobes. Each lobe contains smaller units known as alveoli. Each alveolus is surrounded by a network of capillaries. The alveoli are the site of gas exchange between inhaled air and blood. The alveolar walls are composed of a single layer of flat epithelial cells and are very thin. They are strengthened by elastic fibers that allow the alveoli to stretch and contract. The lungs of an adult human contain about 700 to 750 million alveoli, providing a surface area of about 100 to 150 square meters for gas exchange. The lungs are covered by a serous membrane or pleural membrane, which attaches them to the ribcage and diaphragm. The narrow space between the lungs and the ribcage wall is filled with a serous fluid.
Okay, so that explains the internal structure of the lungs. We have the bronchi, which are the 2 branches of the trachea. This is the function here is the airway in respiratory tract that conducts air into lungs. Then the bronchioles. Bronchioles, these are the smaller tubules. What is their function? To transport gases to and from the alveoli, which is the respiratory Bronchioles are the smaller tubules. They transport gases to and from the alveoli, which is the respiratory surface. Then you have the alveoli. The structure of the alveoli is the moist, single-layered, sac-like structures of flattened squamous epithelial tissue. These ones increase surface area to volume ratio. They increase the rate of diffusion of gases. The gases are oxygen and carbon dioxide. So these play a very, very important part in gaseous exchange. Then you have capillaries, which are networks of blood vessels around each alveolus, thin squamous epithelial tissue called the endothelium. These ones promote easy diffusion for the respiratory gases. We'll discuss these more later. The pulmonary artery entering each lung divides into arterioles. The capillaries reunite to form venules. They in turn join to form pulmonary veins that leave the lungs. So the veins leave the lungs. Ne? Then the muscles here, we have to discuss as well as the muscles that control inhalation and exhalation. Because you know the lungs are, it's a process, it's not just standing still. Because of the friction, remember I mentioned the pleura, which is there to reduce friction. Muscles are involved in those processes. So these are the muscles. It's not just the lungs, it's not just the capillaries that are involved in the process of inhalation and exhalation. We also have muscles, and these are the muscles that are involved. We have the ones shown in purple here, which are called the stenomastoids. Stenomastoids are over there by the sternum. Then you have the scalenes there. You can indicate it's those ones, the small, as if it's legs in a way. And then you have the inspiratory intercostals. Inspiratory intercostals are the ones here in pink. In pink, this side here, in between those ribs there. Then you have expiratory intercostals. Those ones are there highlighted in green. You have the diaphragm. There's your diaphragm. You know your diaphragm, right? The diaphragm is in that region just below that lung area. It's there, that diaphragm. Then expiratory intercostals again, they're on both sides, they're green. Both sides. And then you have the external obliques. External obliques, they're further down from the rib cages there. Then you have the expiratory abdominals. Expiratory abdominals. So they're by the abdominal area, but the upper abdomen, you know we have the lower abdomen and upper abdomen. These ones are there by the upper abdomen part of your body. They are expiratory abdominals. These breathing muscles, the following muscles make breathing possible. So breathing wouldn't be possible without these muscles as well. I know whenever we speak of breathing and the respiratory system, we hardly ever mention muscles, but they are very important as well. They help either with inhalation, which is breathing in, or exhalation, which is breathing out. There is more detail on their functioning on this next page we'll discuss here. Then, the structure and function of these breathing muscles, we need to discuss that. This is extracted from via Africa Life Sciences grade 11. Yeah? The part, the diaphragm, this one here. There's the diaphragm, this one, this whole part in red. This part here. Diaphragm, the structure, it's a muscular structure below the rib cage. It is convex or dome shaped. You can even try and touch it there. Below your rib cage, immediately below your rib cage, you have the diaphragm over there. Just try and maybe identify it somehow there. That's your diaphragm. It's over here. You see, it's giving you a direction. So if you can try and locate it on your body over there. It separates the thoracic, which is the chest cavity, and the abdominal cavity. So the abdomen, the diaphragm is the one that separates your chest from your abdomen. So it's the chest cavity, which is also called the thoracic cavity, and it separates it from the abdominal cavity. So as soon as you go below the diaphragm, you've got your abdomen. If you go up above the diaphragm, you have your chest. So that's how your body is separated. It is responsible for inhalation. It also protects that part area there. And then the external intercostal muscles. These muscle fibers that are between the ribs on outside of the rib cage. Hence the word external. Oh man, I'm highlighting the wrong part. External, why? They are on the outside of the rib cage. These are muscle fibers that are between the ribs. Let's look at the external ones here. These ones that are called the expiratory intercostals. They are on the outside. They are on the outside. They are called what? External intercostal muscles, or they are called expiratory intercostals. So you can use those two terms interchangeably. These muscle fibers, we have said they're between the ribs and outside the rib cage. So you see here, they are between the ribs. You see here, between the ribs, but outside of the rib cage. They help the diaphragm during inhalation. So they're there to assist the diaphragm during inhalation. Then you've got the abdominal muscles, which are just below your diaphragm there. The flat muscles of the abdomen. Flat muscles just below the abdomen there. Abdominal muscles there. Those muscles over here. They force the air out of the lungs during exhalation. So these assist during exhalation. They force it out. Those muscles force the air out of the lungs. Then you've got the internal intercostal muscles. They are also called the inspiratory intercostals. Inspiratory intercostals. Those muscle fibers that are between the ribs on the inside of the rib cage. Inside, internal. There outside, it's external. You see those keywords, they will guide you. They are both also in between the ribs, much like the external intercostal muscles. The difference is these ones, the internal ones, are inside the rib cage, and those ones are outside of the rib cage. Let's look at the these ones here. Inside the rib cage here, they're inside. You can see here, those are inside there. So you need to be able to identify and understand these. So whenever you're asked a question about the breathing muscles, this is what you need to discuss. This is what you need to remember and identify. Then now we are discussing the ventilation of the lungs. Ventilation of the lungs is what? The flow of air in and out of the alveoli. The flow of air in and out of the alveoli is called what? Ventilation. Remember the alveoli. What is the alveoli? Where is that diagram of the alveoli? Let's go find that from the previous work. I want to show you a clearer one. We had a... no, it's not here. There. Those sacs, those small sacs. There. Those ones, the air flows in and out of those ones. Remember? I'm not gonna go through that. This is surrounded by a network of blood capillaries, and gaseous exchange in lungs happens between the alveoli and blood capillaries. So those are the alveoli. It is also it's the moist single-layered sac-like structure of flattened squamous epithelial tissue. So those sacs, those balls of sacs that I showed you, those are the alveoli. They are the ones that are mainly playing a crucial role in ventilation. How? The flow of air in and out of them is called ventilation. So the air flows in and out of them. Ventilation happens by the thorax moving and changing size with the help of what? Of the intercostal muscles and the diaphragm. So a lot of things, a lot of structures are involved in the process of ventilation. It's whereby the thorax is moving and it changes size with the help of those muscles, the intercostal muscles and the diaphragm. Remember, we just discussed intercostal muscles. You have the external ones, you have the internal ones. Then you have also the diaphragm and the abdominal muscles. They all facilitate the process of ventilation of the lungs. The process now, the ventilation, the process of inhalation and exhalation. When you're asked to list the differences between exhalation and inhalation, or the process of what happens, inhalation is an active process. The body actively allows air inside. The diaphragm does what? It contracts and flattens. When it contracts, it closes. Ne? And it closes, it flattens, it gets smaller. Then what happens? The intercostal muscles will also contract as this happens. And as these muscles contract, the rib cage will be lifted upwards and outwards. You'd realize this when you are, how do I explain it? When you are breathing in, when you are inhaling, you are taking in the air there. Ne? Then the rib cage would be lifted upwards and outwards. That's what happens. Then the abdominal muscles would relax. When the abdominal muscles relax, it means they open up, they dilate. Then the thoracic cavity. What is the thoracic cavity? Remember, we discussed the thoracic cavity. It's the chest cavity. It enlarges so that the volume increases. Why? To make space for the rib cage moving upwards and outwards. Make space for that. And then the make space also for the air coming in. That's why the volume is increasing. Pressure in the thoracic cavity drops. You remember the relationship between pressure and volume. I think we discussed it with you, ne? Whereby when you increase the volume, it decreases the pressure. But if you reduce volume, then pressure increases. So they are indirectly proportional to each other. So as the thoracic activity, the thoracic cavity enlarges, which means the volume increases, more space is provided for the air inside. The pressure on this cavity here, on this chest area, drops. Then oxygen-rich air is drawn into the lungs. So there's enough space now for this air, and it comes in to the lungs. It is drawn in. You see, it's drawn in. But the process of exhalation is the reverse of that. It is passive instead of active. So no energy is required for passive. It's just, it happens easy. The diaphragm here would relax and it becomes dome-shaped. It would relax, it becomes dome-shaped. So you see, these are opposites of each other. In inhalation, the intercostal muscles would contract, but in exhalation, the intercostal muscles relax. Then the rib cage would move downwards and inwards. Then the abdominal muscles also contract now. So the abdominal muscles do the opposite of what the diaphragm and the intercostal muscles do. When the intercostal muscles and the diaphragm relaxes, the abdominal muscles contract. But if the diaphragm and intercostal muscles contract, then the abdominal muscles would relax, and that would happen in inhalation. The thoracic cavity would decrease, volume decreasing, meaning now it's making way to release the air. It no longer needs all that space because it is releasing the air from the body. Then the pressure, like I said, the relationship between pressure and volume, when you decrease the volume, you increase pressure. Pressure in the thoracic cavity increases. Then the carbon dioxide-rich air is forced out of the lungs. Let me highlight the keywords to the key differences. It's an active process in inhalation. In exhalation, it's a passive process. Here, that in inhalation, the diaphragm would contract and flatten, whereby in exhalation, the diaphragm relaxes. In the intercostal muscles contract, whereby in exhalation, the intercostal muscles relax. The rib cage during inhalation would be lifted upwards and outwards. Yeah, but during exhalation, the rib cage moves downwards and inwards, exact opposites. The abdominal muscles would relax, doing the opposite of what the diaphragm and intercostal muscles do. And in exhalation, the abdominal muscles would contract. The thoracic cavity would enlarge, meaning the volume is increasing. Thoracic cavity enlarges, the volume increases, but during exhalation, the thoracic cavity decreases and volume decreases. As with the relationship between pressure and volume, pressure here would then drop because there's an increase in volume. But during exhalation, pressure increases because there's a decrease in volume. Then the most important one, during inhalation, it's oxygen-rich air that is drawn into the lungs. That is what you want during inhalation. This is the end goal. You want this oxygen here. But during exhalation, you are forcing out the carbon dioxide-rich air. It is forced out of the lungs. So these are the processes. So as long as you've got this on lockdown, you understand this work. So study it, refresh your memory after this so that it's easier. Can learn together, ne? Then, this is explaining what we just did here. This process of what this inhalation on this side. On this side, left-hand side, my left-hand side, yours as well. It's the process of inhalation. The rib cage moves up and outwards. You see, the rib cage moves up and outwards. Diaphragm contracts and moves downwards. The diaphragm is contracting, moving downwards. Pressure in the lungs decreases and then air rushes in. As the diaphragm contracts, the rib cage moving upwards and outwards, then the pressure in the lungs is decreasing because you see it's moving in opposite directions. If it's moving upwards and outwards, the diaphragm is contracting, moving downwards. It's making more space now. There's no more pressure now. The volume has increased. So because the pressure is low now, the volume has increased, then the air rushes in very easily, can go in very easily. Then you are inhaling here. The air is going in easily. But when you are exhaling, the rib cage will move down and in. There is the rib cage moving back down and in. You can even see the differences in sizes here. The diaphragm would relax. When the diaphragm is relaxed, it means it moves upwards. You are reducing the volume. You are decreasing the volume. Thereby, what are you doing? You are increasing pressure in the lungs. When you increase pressure in the lungs, then the air is pushed out. Because here it's literally you're constricting this area, right? You're constricting it when you're reducing the volume. So the air is forced out, it is pushed out. That's when you exhale. Again, you exhale. This here is showing you the pleural membrane. Remember the pleural membrane? That is protecting the lung area there. Then you have your diaphragm over there. So I hope this is clear. I hope you understand this. Now feel free to ask me any questions if you have a problem and you need to understand. I'm here for you. And then gaseous exchange in alveoli. So we just explained what happens in the lungs. Now let us explain what happens in the alveoli. When you breathe in, oxygen-rich air moves through your nose or mouth into the nasal cavity, through the pharynx, larynx, and trachea. We discussed this earlier in the week, I think yesterday, if I'm not mistaken. When you breathe in, the air moves in through your mouth or nose. Remember, it comes in through your mouth and nose, passes into the nasal cavity, through the pharynx, larynx, and the trachea. The air then flows through the trachea, as we've seen that structure of the trachea, then into the bronchi. Remember, you have two bronchs. You have one on your left, one on your right, directing you to either the left lung or the right lung. And from the bronchs, they branch out into what we call bronchioles. Bronchioles, they are like smaller branches of the bronchi, which carry the air into the alveoli. So at the end of those bronchioles, you've got the alveoli. So remember, like that is your trachea. Then it will go in here. This side, it is the left bronchi, right bronchi. There. Then you have your lung. I can't draw, guys. Forgive me. There you have your lung. You have the other lung over here. There. There. Then inside there, this bronchi, it will branch out to smaller bronchioles. These are lots and lots of branches of the bronchi. They branch out. Then at the end of those bronchi, you've got alveoli there, those small sacs at the end there. Then they are the ones that will allow the air to move in and out of the lungs. There. You see, this is not a clear picture, but it's just showing you exactly what goes down. The smaller lines there, the branches are bronchioles. This is the bronchi, this one here, the bigger one, much like a tree. So we'll say this is the branch. Okay, but branches are a lot. What can I use as an example? Maybe this is like, yes, this would be a stem. This would be your branch. Then the smaller branches that form from the main branch. Yeah, let's just say that. Or those smaller branch that branch into the, yeah, let's just say that. I think it's clear enough example for you guys. The air then flows through the trachea, bronchi, and into the bronchioles, which carry the air into the alveoli. The bronchioles is the one. Remember, the air is coming from this, it's coming through the trachea here. Then it's moving into the bronchi. Then the bronchioles into the SX there, which is the alveoli. They carry, the bronchioles are then the ones that carry the air eventually to the alveoli there, those small sacs. So the air is there in those small SX. The alveolar walls are surrounded by a close net of blood capillaries. We read that the alveolus are, it's surrounded by those blood capillaries, lots and lots, a network of blood capillaries surrounded by it. The oxygen in the alveoli diffuses from a high concentration through the alveoli walls into the blood capillaries, which have a low oxygen concentration. So these blood capillaries that are surrounding this alveoli, they are low in concentration of oxygen. So remember the process of diffusion, you learned it in grade 10, the oxygen would move from a high concentration in the alveoli to the low concentration in blood capillaries. They move through these alveoli walls, meaning they're permeable, right? That allows the movement of those oxygen particles, oxygen molecules from a high concentration to a low concentration. And this oxygenated blood leaves the lungs through the pulmonary veins. So now the oxygenated blood would leave the lungs through what? The pulmonary veins and returns to the heart for pumping around the body. So the oxygen will leave through the lungs, through pulmonary veins. You understand here? So the capillaries, the blood capillaries here will carry this oxygen to the lungs. And then this oxygenated blood will leave from the lung through the vein, through the pulmonary vein, where it takes it to what? To the heart. Takes this oxygenated blood to the heart for pumping. Why the heart? Because then the heart will be pumping the blood, this oxygenated blood, throughout the whole body where it is required. That's why the heart is the main pump of the body. So it will pump it to every other part of the body that requires this oxygenated blood. So this is a process of bringing oxygen to the entire body, from when you inhale this oxygen air to how it gets into the lungs and how it leaves the lungs through the veins, pulmonary veins, to the heart. Then from the heart, it is pumped to the rest of the body. But when you breathe out, carbon dioxide in the blood capillaries will diffuse from a high concentration through the alveoli walls into the alveoli because they have a low carbon dioxide concentration. So it will take, the lungs are pumping now, ne? Then they're pumping out this carbon dioxide. The blood capillaries then take this carbon dioxide rich blood, because then in the capillaries, these blood capillaries, there'll be a high concentration of carbon dioxide blood, or it's what's oxygenated, deoxygenated blood. It's the blood with carbon dioxide. There's a high concentration of that carbon dioxide blood in the blood capillaries. It would diffuse again from a high concentration. The high concentration is in the blood capillaries, to the low concentration. The low concentration is in the alveoli, through the alveoli walls. The alveoli walls act as that membrane here, the cell membrane. To the alveoli, because the alveoli has a low concentration of carbon dioxide, right? So it's a process of diffusion, once again, a movement from a high concentration to a low concentration. It's down a concentration gradient right now. Then as it moves there, it then follows the reverse path out of the body. The reverse path. Remember, the same way it came in, now it's what's going out is the carbon dioxide. What came in was the oxygen. So through all those processes, from the alveoli, then through the bronchioles, then the bronchi, then trachea, then out through the mouth or the nose. That's what happens. That's the process in reverse right now. So please understand these parts and how they link to each other. Here, this is how does gaseous exchange in the alveolus occur. How does gaseous exchange in alveolus occur? Where do we start it here? You have your red blood cells. You have the epithelium of the alveolus. You have carbon dioxide, which escapes into the alveolus through diffusion here. This carbon dioxide was moving through diffusion to the alveoli, moving because there's a high concentration of carbon dioxide here. It will move to a low concentration of carbon dioxide in the alveoli. Then it's the process from the alveoli through the bronchioles to the bronchi, through the trachea, up there, up until it's out from the mouth or the nose. That's what happens during exhalation. But during inhalation, the air would come in through what? The blood capillaries. Again, the process of diffusion where the blood will, through diffusion, it's now in the alveoli, right? It's moving through the air. From there, it's moving there into the alveoli. Then it will enter into those cells there. Then remember, the pulmonary veins are then collecting the oxygen-rich blood from the lungs as it has pumped it, carries the oxygen-rich blood from the lungs, takes it to the heart. The heart will pump all that oxygen to every other organ that requires oxygen in the body. I hope you understand that. Is it okay? The pulmonary arteries bringing the deoxygenated blood to the lung area. Is it clear, guys? I'm done. That is it from me today. That is the topic. The textbook I used is the Via Africa Grade 11 Learner's Book, accessed from the Snaplify app. This is a great app. I think people would probably even think Snaplify is paying me, and they're not. But it's so great. Use it. Go look for the textbooks that you need on Snaplify. It will be very, very helpful for you. You'll have free access to the Snaplify app, and you'll be able to download these books for free up until December this year. After that, chances are we'll continue with the paying method. For now, make use of this. It's there at your disposal. You have all the resources at your disposal, so you can't make any excuses, really. If the one textbook you have doesn't provide sufficient information to the questions you are doing, and I'm assuming maybe you are working also with past papers, if it's not sufficient, go download other textbooks to help you get sufficient information. It is really, really helpful, and it is for your own good. So make use of all resources at your disposal, guys. Nothing is stopping you. We are gunning for straight A's here. So please spend more time with your books, ne? That is it from me today. Any questions? Okay, if there are no questions, then I will see you tomorrow and we will finish up with the topic. Thank you very much for your attendance, everybody. Bye.